Our last type of example for this lesson is given one trig function's value and one other piece of information, we can determine the exact value for the other 5 trig functions. Now the reason we need one other piece of information is because every trig function is positive in 2 quadrants and every trig function is negative in 2 quadrants, so we need to narrow down exactly which quadrant we're in order to exactly find the other 5 trig functions. So this example says that the cosine is -4/5 and theta is in the 3rd quadrant. Remember, cosine is negative in both the 2nd and 3rd quadrants, so the fact that theta is in the 3rd quadrant completely narrows it down for us. So I'm going to draw a triangle with theta pointing towards the 3rd quadrant, and I'm going to set up that cosine is the adjacent over hypotenuse, and then we can use Pythagorean theorem to solve for that missing side. Now some of you may recognize this as Pythagorean triple, and you may not need to set up Pythagorean theorem to solve for y. For those of you that don't, just go ahead and run through this quickly, subtracting 16 from both sides, and of course theta being in the 3rd quadrant, we know that we're taking the negative square root of 9. Now that we have our triangle set up exactly, we can set up quickly with SOHCAHTOA our other 3 trig functions. So sine is opposite over hypotenuse. We already know the cosine, so we can jump to tangent. Will of course be positive in the 3rd quadrant. We'll have a negative over a negative, which will simplify to a positive. Cosecant flips the sign, so we have -5/3. Secant flips the cosine, so we have -5/4. And finally, cotangent flips our tangent. Our last example, we know that cosecant, which is the reciprocal of sine, is positive. Sine is positive in the 2nd and 1st quadrants, and the cotangent or tangent is negative, which occurs in the 2nd quadrant. So we are going to set up our right triangle facing the 2nd quadrant. Cosecant being the reciprocal of sine, instead of being opposite over hypotenuse, this is hypotenuse over opposite, and then we can use Pythagorean theorem to find our x value. So we have 1 squared plus x squared equals 4 squared. 4 squared, of course, is 16. Subtracting 1 from that, we get 15. So x is negative square root of 15 because we know we're in the 2nd quadrant. Now we can set up our other 5 trig functions. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, which is already rationalized, so that's nice. Tangent is opposite over adjacent. This one is not rationalized, so if you remember that shortcut, bring the radical to the numerator and just drop it in the denominator. We already have cosecant set up, so we're going to jump to secant, which is the reciprocal of cosine. Using our shortcut to rationalize again, we move that square root of 15 to the numerator, and we drop the radical in the denominator. And for cotangent, instead of taking the reciprocal of the rationalized one, I'm going to take the reciprocal of the unrationalized one, and then I don't have to rationalize again. And your 2U try problems.